Okay, guys, how's it going out there? Rooster and 10, roostercb.com. And this is going to be one of the, I guess you'd say, CB radio basics type videos. It's been highly requested for me to do one of these. I've kept promising people that I would. And hopefully it helps some folks out. Again, it's going to be a very basic video. So any of you guys that are well versed or well experienced, this is probably going to be redundant information for you, and it's going to be pretty basic. I'm not going to go into super detailed stuff. So if you think, well, dang, he left a lot out, all I'm doing is trying to get to the basics to get somebody by. If we want to get into specifics, obviously, there's a lot of information that folks can Google out there. Some opinionated, some theoretical, I guess I'd say, and some that's scientific information that you can find out there. The information that I typically offer is from my experience. I'm not the CB professor or some sort of electrical engineer. The information and advice that I give you guys is through experience and typically through opinion that I have gained through that experience. The video subject of the day is going to be how to hook an amp up to your radio. You know, this can all obviously be used for ham, CB, whatever. It's, you know, essentially the same practices, hooking one up or the other. We'll be kind of talking about hooking a mobile amp up or an amp that runs off a power supply. But when it really comes down to it, it's the same basic principles when you go to hook up a bass amp. The only difference is you're going to be plugging one in the wall, and the one that runs off a power supply or what have you, you're going to be running it off a battery, or if you're in a bass, a power supply. Again, I like to do these videos because a lot of information, I think back when I got into radio, a lot of information was not available, and you were kind of at the mercy of your local mentors or fellow operators, and it still goes on today. A lot of people like to gatekeep stuff, and they don't like to share because they don't want you to get bigger than they are in the hobby. That's a whole different video, a whole different subject for another time, but that's just kind of the way it is, unfortunately. I enjoy talking on the radio. I want to keep people talking on the radio. 20 years from now, I want there to be someone, when I key the mic up, I want there to be people that I can talk to. Another reason I do these videos, aside from, obviously, I sell this stuff. Okay? So let's get started here. Let's talk about it. Again, feel free to comment if you have other information. You can disagree with me respectfully, of course. Share that. I'm not going to get mad at you if you disagree with me. If you call me an idiot or something, you know, I'm not going to like that. But we can all respectfully disagree. But I'll jump right into it here, guys. All right. So starting out, the very most basic things that you're going to need, when you're getting ready to hook up an amp to your radio. You've been talking for a while, but you're not getting out as far as you want to. You want to boost your range a little bit. You know, you're in a mobile or whatever, and you've only been able to talk 4 or 5 miles up the road, and you say, well, man, I'd like to be able to talk 20 or 30 miles up the road. That'd be great. Well, outside of improving your antenna, the next biggest step you can make is to hook an amp up, whether you're ham, CB, whatever. So obviously the first thing you're going to need is an antenna or a load. That's the last thing in line that's going to come into your setup is an antenna. So I would highly recommend, before you ever invest in an amplifier, you buy the best antenna that money can buy for you. Whatever is in your budget, the best you can afford. That doesn't mean buy a little wheel. Okay? If you're buying a little wheel magnet mount antenna, then you don't need to be buying an amplifier. You need to be buying a good antenna. You guys can ask me my opinion, what good antennas are, but, you know, obviously anything I sell on the website I consider good. Now, there's other good antennas out there, but that would be a good place to start. So it all starts with a good antenna. Before you ever hook an amplifier up to your antenna, you need an antenna analyzer. Okay, some people will say, well, they don't really need an analyzer. You can use a watt meter I don't trust a watt meter to check the SWR. I recommend someone buying one of these, borrowing one of these, or go to a reputable shop that sets your SWR on your antenna with one of these. If you go to a shop and they come out to your truck and they're trying to set your SWR with something that looks like this, go somewhere else, okay? When you're setting your antenna up, it needs to be set up with an antenna analyzer. That is the best way to set up your antenna. This thing is going to tell you stuff that little meter can't tell you. In addition, this is going to be far more accurate than a watt meter, okay? Why is this important? What does this do? You adjust your antenna for the lowest SWR. And what is SWR? That is your standing wave. Okay, in basic terms, what your SWR is going to calculate, what that number turns into, is the amount of power that makes it out your antenna versus the amount of power that's coming back to your radio or your amplifier. The higher your SWR, let's say you have a 1.8 or a 1 to 8, it's a ratio, a 1 to 8. That is a relatively high SWR in the CB world. And what that can do is, I'm just going to use this as an example, speaking very generally, but let's say you have a 500 watt amplifier and your SWR is a 1.8, and just ballpark reference, you have 450 watts or 500 watts going out, but out of that 500 watts, you have 50 or 60 watts that is coming back down your coax and going back into your amplifier. What that will do is eventually burn your amplifier up. That is why this is the most important tool that you can use before you ever hook up an amplifier. I've talked about this in videos before, but it is extremely important that you get your SWR as low as possible. And when I say as low as possible, I don't mean a 1.5, okay? Highly recommend a 1.3 or lower. Personally, myself, if it's over a 1.1, you know, I'm probably not going to talk on it. Even though it'll be fine, I want my SWR to 1 to 1. Remember, it's a ratio, or lower. And your impedance, because this thing reads impedance too. You know, we could have a whole discussion about one of these. But you're going to want it as close to 50 ohms as possible. SWR is good. Impedance is good. You shouldn't have any trouble out of your amplifier in that sense. Okay? That's going to stop it from blowing up because you have a bad antenna hookup. The next thing you're going to need before you ever get ready to hook this up is you're going to need, obviously, the coax coming from your antenna to your watt meter, or if you don't have a watt meter, your amp is going to be the last thing in line before your antenna. You're going to need quality coax. Jumpers is what people refer to these as. Jumpers or patch cables. Ham operators call them patch cables. CBers typically call them jumpers. Now, what does that do? What does the jumper do? That is going to link one piece of equipment to the next. So let's say you start with your antenna, and then your antenna coax is going to screw into the back of your watt meter, and then you're going to run a jumper from your watt meter to the back side of your amp. Now, as far as that goes, let's turn this amp around and talk about this a little bit. Every amp ever made, I don't care if it was made in 1970 and it's a Heath kit, or if it was a Carl built that was made yesterday, they're going to have at least 2 connections on the back. Most commonly, SO239. That's what this is. It's the female companion to the PL259. Sometimes they'll be labeled out and in. Sometimes they'll be labeled input, output, and sometimes they'll be labeled antenna and radio. Antenna is the output, as it is going out to your antenna. Radio is going to be the input, or what's going into your amplifier. If you have a high drive amp, you may have a second amp in line, a smaller amp, that runs into your larger amp. So instead of going to your radio, this would go to your driver or your smaller amp that's going to drive your larger amp. Okay, so you need jumpers, coax cables to make that connection. On the conversation of jumpers, highly debated. I have no idea why people get in their feelings about this when I say this. This is, again, my experience. From my experience, you do not want to run less than a 6-foot jumper. If you start running 3 feet jumpers, for whatever reason, you can run into some issues. Okay, your amp can start staying locked up, keyed up, oscillate, which means it's trying to generate power and key up without you making it key up. It's trying to engage. You can find all kinds of stuff that happens. And I'm not here to explain it or debate it. People will say, that's crazy. Jumper length doesn't matter. I don't care. It doesn't matter what you run. If you're one of those people that believes that, that's fine. We can agree to disagree. But I'm telling you, from my experience, I have had those type of issues, especially in a mobile, to where simply putting a 6-foot jumper in line or a 6-foot patch cable versus a 3 can stop that from happening. No 3-foot jumpers. If you contact me and you say, Rooster, I don't know what's going on with my amp, I hooked it up, and it just keys up. It locks up as soon as I turn it on. The first thing I'm going to ask you is what length of coax you're running, what length of jumper. And if you tell me a 3-foot jumper, I don't know what I'm going to say. It's not going to be good because I've beat the dead horse about this, okay? And I can tell you about a dozen times a year, somebody contacts me about that, and I tell them, hey, what kind of jumper are you running? What length are you running? And they'll say, well, I've got a 3-foot jumper going from my amp to my watt meter. I say, hey, man, change it just for my peace of mind, change it to a 6. They change it to a 6, and magically, all their troubles go away. Now, you can also run different lengths of this. 6, 9, 12, 18. You can run specific wavelengths, which is another conversation. People will null these out to where there's no reactance. Using, again, an antenna analyzer, they'll trim them to a specific length, and essentially it makes the jumper invisible. Okay? It's like your system doesn't know it's there. Very handy to do. I'm not that particular on my stuff. I've got by running 6, 9, and 12 feet jumpers for the majority of my life, but I'm not saying it's a bad thing. They call it nulling out your coax. I'm not saying that's a bad thing. You know, used to the golden rule was 3 feet increments, but again, nulling your coax out with an analyzer, I'm all for it. If you want to do that, more power to you. It's not going to hurt. It can only help. Okay, what else do we need? We're hooking our amp up in line. Well, you're going to need a watt meter. Now, there's 2 watt meters you can see in this video, the little cheap Radio Shack here, and the bird meter in the background. The Radio Shack one is a excellent little meter for the money. It's a reference point. Bird meter, obviously, when you're in the end game of radio and you've kind of bought everything you already need, and you're running an expensive station, you're probably going to run a bird meter. It's the industry standard. It can read output. It can read reflected power. It's what everybody uses that's kind of at the top of the game. They use it as a reference. So if you're serious about radio, you're spending thousands of dollars, get a bird meter. If you're like $1,000 or less in the radio business, then there's all kinds of different options out there for you that are cheaper. But you're going to need a watt meter. Okay. Next thing you need to know, SWR, we've already covered that, is making sure you have enough power supply to run your amplifier. Specifically, if you're running an amp like this that has a hot and a ground, it's going to hook up to a battery, a 12-volt system, 15-volt system, whatever. You need to make sure you got the right voltage and the right amount of current or amperage to supply your amp. If you don't have that, if you've got that messed up, then everything we've already talked about isn't going to matter because you're going to fail. And that goes the same way with everything I'm discussing in this video. If you skip a step on this, you skimp on one part of this, then you have worked hard for nothing. because if you have a good SWR, you got your watt meter in line, you've got good coax, but your amplifier requires 200 amps and you're only supplying it with 100 amps, guess what? That's a problem. If your amplifier is required to run no more than 15 volts and you put 16.5 volts into it, that is a problem. That's going to blow your amp up. So it's very important to know your power supply, how many volts it's pushing out, and if it has enough amperage or current to power your amplifier. Because if it doesn't, you're not going to see the optimal performance or the max power out of it. Now, obviously, antenna, watt meter, coax, amplifier, all that is going to come back and hook up to your radio. And that is also a very important factor. When hooking up an amp, you need to know how much power your radio is producing. There are there's 3 different measurements I want to talk about when it comes to how much power. Every amplifier is going to require a different amount of power. Now, obviously 2 amplifiers that are exact same are pretty much going to take the same amount of power. One of them may do a little more power, one of them may do a little less. But if you have, let's just say, for example, you have a very basic, let's say a 4-pill, okay, a 4 transistor amp that has 4 2879 transistors in it. The transistors are what generates the power. And let's say that amplifier requires 100 watts of input to get 800 watts out, or 100 watts of input to get 900 watts out. Then you have another amp like this one that is a 1 drive and 2, and it only takes 35 watts of input. Well, every amp is different. There's not one universal amp that runs optimally with everything, okay? You can overdrive them, put too much power into them, that's going to blow it up. You can underdrive them, that's going to make you not see all the power out of it. But let's talk about the different measurements of power. 2 terms I want to refer to. Dead key, or carrier, as some people will call it. That's the amount of power that your radio is going to do when you're not speaking into the mic. You key the mic up, you don't say anything. How much power is the radio doing? That is your dead key. Okay? If you key the mic and speak into it, the amount of power that your radio doing is your modulated power. There's 2 different measurements that people use in the radio world for your modulated or swing, if you want to call it that. A lot of people say, how much are you swinging? All they mean when they say that is how much is your radio doing when you're talking in the mic or when you whistle into the mic, whatever. 2 different measurements for your swing or modulated power. One is going to be PEP, or peak power. That's the most commonly used reference point. The other is going to be average power, or some people will say RMS. Average is the amount of power that a bird meter will read if it doesn't have a peak kit in it. It's going to be significantly lower. And without getting into the scientifics behind it, it's the best way for me to put it is it's kind of your raw horsepower. Okay? PEP, or peak, is how you measure the percentage of modulation from your carrier or dead key to your modulated power. Peak measures modulation, basically. Again, we can go into in-depth talking about the 2 different measurements. But more so, average power is more connected with, how much current your amp is going to draw, and honestly, how hard your amp is going to be driven. If your radio is doing 10 watts average or 100 watts average, okay, it matters. That's the way you're going to kind of really the best measurement to measure how hard you're driving your amplifier. Peak matters, okay? Peak is a factor, but average power is more of a deciding factor. Again, put my disclaimer on there. In my opinion, Okay, so now that we've kind of talked about all this stuff, we've kind of got an outline here. I'll try to do a step-by-step of hooking this up. I may pause the video as we kind of go along, but we'll try to be very thorough. Again, guys, I get it. It's basic information, but people ask for this stuff. So here we are. Okay. So we're going to use my test table here as kind of a simulation of hooking up a amp. We're going to kind of talk about it as we go through here, but we're going to get the amp out of the way because we haven't done our necessary steps that we need to do to hook our amp up yet, because we're definitely not going to hook an amp up without making sure our antenna's good, because if we hook it up and our antenna's bad, guess what? We could blow our amp up before we ever get started. And then we're going to call Rooster or Derail or Truck or, you know, whoever. We're going to call them or text them and be like, man, you sold me a freaking bad amp, dude. I hooked it up and I keyed my radio up one time and it let out smoke. And then they're going to say, well, that's funny because it got tested at Carlbuilt and it got tested at Roosters and it worked fine, and somehow when you got it, it just went to shit. Okay? That happens all the freaking time. People just get these amps and they can't wait to hook them up, get them in line. They hook them up, and little did they know that their SWR was like a 1.7. Their impedance was a 32 ohms, and they had 100 watts of reflect coming back for every 500 they put out. Don't be that customer. Don't be that Seabeard. Do your part. Set yourself up for success. It's not like buying a TV from Walmart and you come home and you either plug it in and it works or it doesn't work. It's not like, you know, buying a coffee maker. You either makes coffee or it doesn't. There's a lot of variables in radio, and there's a lot of responsibility on the operator to make sure their setup is right. I'm not going to be there to help you set your antenna up. You know, Trucks isn't going to be there to help you set your antenna up. Derail, whoever you deal with out there, okay, it's your responsibility to make sure your station is set up properly to run your radio equipment on it. Your responsibility. All right, so we're going to pretend that black piece of coax to the right is coming from my antenna. It's actually coming from my dummy load, but a dummy load is a simulated antenna, if you will. We're going to pretend that that's coming from my antenna, and we're going to pretend that I've already checked the SWR and I've got a 1.0 SWR, and we have gone into our watt meter because we needed a watt meter to make sure our radio and our amp were doing the proper power. So we got our watt meter in line, but we're going to double check anyway, and we're going to make sure that our watt meter isn't making us have a high SWR. Because every break you have in your system, there's a chance that the SWR can change. You could have a faulty connection. You could have a bad watt meter. You could have a bad input, output on your amplifier, whatever. So we're just going to check before we ever put our amp in line. And we're just going to do real simple here. All parameters. We're going to hit a check mark. And again, we're not going to get into real depth on this analyzer, but we got a pretty good rating here. Our SWR is a 1.07, so we're happy. You know, it's not over a 1.1 or a 1.2. And our impedance is 47.1. Would we love it if it was 50? We'd love it if it was 50. We'd like it if it was 52, 50, 48, whatever. But it's close enough. It's not going to matter. Main thing is our SWR is good. Our impedance is fine. That's not far enough off to matter. So, from this portion, we are A-OK to hook our amplifier up as far as that goes. Now, this is our power supply over here, okay? This is my power supply leads. We're going to hook it up last. That's when we'll fire everything up, but we know that our power supply is 14.8 volts because we've used a multimeter to check it. And we know that we've got 200 amps worth of power supply. So we're going to be good in that department. We've done our due diligence. We know we have enough power supply to run our amp. We know that our voltage isn't too high. So that portion we're A-okay on. Okay. Now, remember what I said. All your amps, whether it's a bass amp, mobile, whatever, they're all going to have an input and an output. Input's going to be radio, output's going to be antenna. What happens if you get these mixed up? Okay, what's generally going to happen is when you go to talk on it, the relay inside is just going to go click, 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 because it can't do anything else. The amp can't generate power because you're basically trying to go in reverse. You're trying to make it do power, but you don't have anything going into it because your radio is hooked up where your antenna should be, essentially, okay? Sorry about that. I had ran out of memory on my camera, so I had to pause it for a second. Okay, so that's what happens if you hook your radio up to your amp backwards. It's just going to sit there and continuously click, 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 click. Okay, so all we're going to do here, this is going to be coming from our watt meter or your antenna, whichever's last in line. This is your output coax. You're just going to hook it in. Make sure it's nice and snug. Screw it in there. And then, obviously, again, I know this is probably too thorough, but we're just showing how it's all hooked up here. We're going to take our jumper or our patch cable here, and we're just going to hook it in right here. Okay, and then the other end is going to go to our radio. This is a low drive amp, so all we need to run into it is our radio. And our radio doesn't do more power than necessary to run our amp. This amp's going to require, what's it say? Let's see, 40 watts. So our radio's not going to do more than 40 watts. We already know that. If you didn't know that, you would want to double check, make sure, you don't want to hook up an 80 watt radio to an amp that only requires 40 watts. Remember what I said, modulated power and dead key. This reference, again, and you can ask your amp builder this, you can say, well, is that reference, is that 40 watts peak or is that 40 watts average? Is that 40 watts dead key or is that 40 watts modulated? Okay, if you weren't sure, obviously I know he's saying 40 watts PEP or peak power, swing or modulated power going into our amp. So let me pause the video here. We'll get this thing turned around. You guys don't want to sit here and watch me screw coax in, so we'll be right back. Okay, guys, we have made it this far. We have checked our SWR. It's good. We know how much power relatively that our radio's doing. So we know we're not going to overdrive the amp as far as the radio goes. We know how much power that our amp is supposed to handle. So we have set ourselves up for success. We have a good antenna. We have good coax coming in. We're using a quality jumper or patch cable to go in between our radio and our amp. And we're using a quality jumper or patch cable to go between our amp and our radio. Our radio is the first thing in line, closest to us. Then we go into our amp. Our amp goes into our watt meter, so our watt meter can double check how much power we're doing on our entire system. And then from our watt meter, we go out to our antenna. So we have hopefully set ourselves up for success, or we have minimized the bad things that can happen. Now, obviously, from here, stuff still happens. It's not a perfect world. Stuff still tears up. You can have everything perfect and still have a failure. Ask me how I know. But we're going to turn the radio on first. Now, ideally, what you would want to do is you would want to know, remember, two different measurements we're using for power, dead key or carrier, and then PEP or modulated power. Now, ideally, you would want to know the max safe amount that you can run this amp at with everything turned on. And Carl is nice enough to put that on the back of his amps. And it says 100 watts dead key with the amp on, which means with everything turned on, we don't want a dead key over 100 watts. And it says 40 watts input. which is the peak power or modulated power that our radio does. But what he failed to include, or he left out for you to figure out on your own, is how much dead key you can put in from the radio. There's a missing part of the equation. So you know how much the amp's supposed to dead key. You know how much the amp, how much the radio is supposed to swing into the amp. But what you don't know is how much power the radio can safely dead key into the amp. Here's my advice when you run into a situation like that. A lot of radios are going to have what's called a variable power or a variable dead key. If they don't, then you want to set it on the lowest amount possible. So if it has a high and low, you want to set it on low. But you really want to know how low the radio will go and how high it will go. You don't really want to go into that blind. But let's just say you don't know how much dead key you want to put in this amp. It's your first time hooking it up. So you want to be on the safe side. Well, what you're going to do is if you have a variable power, and it's going to be labeled RF power. This one was added after the fact, so it says RF gain. We replaced the RF gain with the RF power. But this is our variable dead key knob right here. You're going to turn your amp on. You're going to turn your variable dead key all the way down. Even if you think it dead keys 0 watts, you're going to turn it all the way down. And what you're going to do is pay attention to your watt meter here as you do this. I'm trying to get the radio and the watt meter in frame here. But I'm going to show you what my advice to do is. You're going to key the mic and see our amp is not even wanting to key up because we don't have enough power going into it. Okay, this is just a safety precaution. You're going to key the mic and you're slowly going to turn your dead key up on your radio. And you'll hear an audible click within the amp. That's the amp telling you, okay, you've hit me with enough power for me to engage or for my relay to key up. That's going to be the bare minimum. Hear it making a noise through my little receive radio back there. That's going to be the bare minimum. Okay, ideally that's not going to be enough. It's probably going to sound like crap because your dead key is going to be too low. But that's going to let you know, okay, that's the bare minimum I can run. This is if you don't have a watt meter. Or, again, if you don't know, if you do have a watt meter, you're keeping an eye on it. If you don't have a watt meter, you can do this. And that way you know you're not overdriving it. But since we do have a watt meter, we're going to key up. We're going to slowly, now see, let me turn this radio off. We're slowly going to raise our power. Well, there we go. We got it to 100 watts. Now we have no idea how much our radio's dead keying, but now that we have got it set there, we can turn our amp off and we can check on our watt meter and know, we can see how much the radio's dead keying. Maybe it's a watt, maybe it's 2 watts, but we've got a mark on our radio now where we know, if you guys can see this, that if we turn this knob to 9 o'clock, that's the bare minimum to get the amp at maximum dead key. Now again, you can run it less than max. Just because Carl says a maximum of 100 watt dead key, that don't mean you got to run it at 100 watts. Personally, me, this amp in particular, I'm going to run it between 50 and 75 watts dead key. Now let's check and see how much power our amp is actually doing. This is with everything turned on. Now for those not familiar with a bird meter, that little gizmo down at the bottom is called a slug or element. That dictates what scale the meter reads. So that's a 500 watt in there. So we're going to look at the middle scale. 50 is going to be 500. So let's key our system up here. Hello, you got a 50 watt dead key, and again, two different measurements, I guess you'd say, average power and PEP. Right now, we're measuring average power. That's our dead key. Hello, that's our average power. we're doing 250 watts average, okay? Now, a bird meter has, if it has peak built into it, it'll have a kit beside that you can measure peak on. This is going to be our peak power. Hello, 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 hello. Over 500 watts PEP. And that's pretty much it. I'm sure I've left some stuff out, but that is a pretty much how to hook your amp up. Now again, different amps are going to be different amounts of drive. It can get a lot more complicated than this if you're running a, you know, a significantly larger amp and you have to run, you know, 2 amps in line before you get to it to properly drive it. It can get, you know, pretty overwhelming and confusing for somebody that's brand new. But for most people starting out, this video is going to set you on the right track. I hope it helps somebody out there. If it helps a dozen people, then that's a dozen people that helped. You know, it may not be life-changing for anybody, but this is my take on it. This is my basic tutorial, I guess you'd say, and that's it. Now, beyond that, what you can do, if you have a bird meter, obviously, is you can double check your reflected power coming back to your amp by turning the slug around backwards. It's facing towards the black coax right now, which means it's checking the output going towards the antenna. If you turn the slug or element around backwards, it'll read the amount of power coming back from the antenna or your reflected power. Now, typically that shouldn't change. If you have a good SWR on an antenna analyzer, that shouldn't change. I don't believe the SWR readings on dosimeters and all that crap when people say, well, man, I had a good SWR and I turned my amp on and my SWR went up. I don't really pay any mind to that. What I pay attention to is if when you turned your amp on, your reflected power started going up on your bird meter. So, you know, if you had, let's say with your amp off, you had basically a perfect SWR, and then you turn your amp on and you've got 100 watts coming back on 500 watts, you know, that's not going to work. That means you've got a bad connection or something going on somewhere. Something is breaking down between your amp and your antenna when that happens. When you have a large amount of reflected power and you've already tuned your antenna with an antenna analyzer, but somehow, some way, when you add, you know, extra power into the factor that in, then you start getting a lot of reflected power back into your system. It means something is typically breaking down between the amplifier and the antenna. Coax, antenna, something's giving you trouble. Okay, guys, that's it. I took a little bit longer to do this than I wanted to, but again, a lot of people have been asking for this. I hope it helps people. Obviously, something basic I left out when you're hooking an amp up, you know, red to red, black to black. I know that seems like common sense, but I've had people ask that. And I'm referring to your wires coming out of the back of your amp over here. Black cable is going to go to your ground, and your red cable is obviously going to go to your hot. Yes, I have had people ask that, okay? Not poking fun, but I have had people ask me that question. And again, guys, this is very basic. There's a lot of in-depth stuff I could get into with types of coax to handle the right amount of power, you know, the right size wire going to your power source, you know, just really a lot of different stuff we could get into, but this is a very basic video. Hope you guys enjoy. I hope it helps some people out. Questions, comments, shoot me a text, 423-299-3535, Rooster in Tennessee, roostercb.com. See you, bye.